Hi, given that 3 power x plus 9 power x is equal to 27 power x, find the value of x. If you go for trial and error method, let's say x is 0, then value of LHS will be 3 power 0 plus 9 power 0, which is 1 plus 1, 2. Value of RHS will be 27 power 0, which is 1. If we say x is equal to 1, value of LHS will be 3 power 1, 3, plus 9 power 1, 9, 3 plus 9, 12. Value of RHS will be 27 power 1, 27. If we see this and this column, right, LHS is going from 2 to 12 and RHS is going from 1 to 27. So there may be a point where x may be 0.6, 0.606 or any decimal. There may be a point between 0 and 1 where LHS and RHS may meet. So trial and error method, we may not be able to solve this equation. We have to go through proper mathematical way. So when we see 3, 9 and 27, we can recognize that 3 into 3 is equal to 9 and 9 into 3 is 27. So that means 9 can be written as 3 square and 27 can be written as 3 square into 3, which is nothing but 3 power 2 plus 3, which is nothing but 3 power 3. So we have 3 power x plus 3 square whole power x is equal to 3 cube whole power x. Now, in order to solve it, we need to rewrite this equation into some other form. Since we already have 3 power x, can we convert these terms in terms of 3 power x? So 3 power 2 whole power x can be written as 3 power 2x because a power m whole power n is equal to a power mn. So 2x is nothing but x into 2, that is equal to 3 power x whole square. So this to this is simply reverse of this. Now we have converted 3 square whole power x to 3 power x whole square. So we have similar logic we can apply here. So we have 3 power x plus 3 power x whole square is equal to 3 power x whole cube. So 3 power x is common across. If I take it as y is equal to 3 power x, we have y plus y square is equal to y cube. So this is a cubic equation. We can try and solve it. If I take y common, we have, now roots of this equation are 1, y is equal to 0, or 2 roots from this quadratic equation. If a quadratic equation is of this form, its roots are minus b plus or minus root over b square minus 4ac divided by 2a. So here a is 1, b is minus 1 and c is minus 1. If I put that in here, minus of minus 1, it will be 1, plus or minus, minus 1 whole square is 1, minus 4 into 1 into minus 1, divided by 2 into 1, which is 2. So minus into minus plus, so 1 plus 4 is 5, 1 plus or minus root 5 by 2 are the roots of this quadratic equation. So y is equal to 0 is one root, second root is 1 minus root 5 by 2, and third root is y is equal to 1 plus root 5 by 2. Since we have taken y is equal to 3 power x, so if we see here 3 power x is equal to 0, so this can never be true. Why? Because 3 power x is always positive. If we put x is equal to 0, we have 3 power x, 3 power 0, which is 1. If we put x is equal to 1, we have 3. If we put x is equal to 2, we have 3 square, which is 9. It goes like that. Now even for negative values, like let's say x is equal to -1, we have 3 power -1, which is nothing but 1 divided by 3. If we put x is equal to -2, we have 3 power -2, which is nothing but 1 by 3 square, which is 1 by 9. So that means as x goes in the positive direction, its value will increase too much, and x, if it goes in the negative direction, -1, -2, -3, it goes very close to 0 but never 0. So y is equal to 0 is not an acceptable solution. Now if we see about this, 1 minus root 5 by 2. So let us see the value of root 5. Since the value of root 4 is equal to 2, root 5 should be 2 plus something, right? So 1 minus 2 plus something is negative, right? This is a negative value. So 3 power x can never be negative. So this is also not an acceptable solution. So this is a positive value. 3 power x, is equal to this is a possible answer. So we have 3 power x is equal to 1 plus root 5 divided by 2. Now we want x, so we take log base 3 on both sides. If we do that, so log of x power n is nothing but n log x. So similarly here we have x into log 3 base 3. Log 3 base 3 is 1. So we have x is equal to log base 3 of 1 plus root 5 divided by 2. This is the answer. For other interesting questions like this, you can check out the playlist linked in the description. Thanks.